So in this lesson, we're talking about 8.5 using intercept form. So intercept form is a new form we're going to talk about. I'm going to review the other couple that we've talked about before. We're going to learn to graph using the intercept form, finding the zeros of functions, and using those characteristics to write quadratic functions and to graph and write cubic functions, although we're not really going to concentrate on that last one. So this right here, this was our standard form that we've been working with, especially when we come to factoring and things like that. And this is our vertex form, the one that gave us the vertex as HK. So you might recall that. So a standard form, vertex form. Now intercept form just gives it to us in a factored form already. So this is basically the same as what you would almost consider like a factored form, because this P and this Q are your zeros of that function. So these are what we would call the zeros or the x-intercepts. So P and Q are your x-intercepts. Your axis of symmetry is halfway between the P and the Q. So if you add the P and the Q together and divide by 2, in other words, take the average of this, then this is going to be your axis of symmetry. So the graph opens up, we know this already, if this is positive, and the graph opens down if this is negative. So let's try a couple and zoom in, straighten that out. Okay, so when you actually do this, you're actually looking for where this intercepts. So remember, when we're finding the zeros of something, you do x plus 2 equals 0, x minus 4 equals 0. And you can solve each of these to get your zeros. You might actually be really good at this right now and not even need to write out those steps, which I'll eventually stop doing in a second, but right now I'm just writing them out so you can see it. So this means that one of my intercepts is at negative 2, 0, and my other intercept is at 4, 0. And if you're trying to find the axis of symmetry, you are going to, I'm just going to abbreviate that to axis of sim. You're going to actually do x equals negative 2 plus 4 divided by 2, so 1. And that is your axis of symmetry. And those are just the two things I want you to find in just these couple of examples. So let's do this one. If you have this set to 0 and this set to 0, you're going to get x equals 2 and x equals 3, right? Because 3 minus 3 is 0 and 2 minus 2 is 0. And that means my points here are 2, 0 and 3, 0. And those points are where they intersect the x-axis. So again, that's the intersection here. So 2 and 3, they'd be like right about there. And that's just giving you an example. That's not actually the graph. So your axis of symmetry is when x equals 2 plus 3 divided by 2, or in this case, 5 halves, which equates to 2.5. All right, let's try it again. This time we're going to find the zeros of the function, and then we're going to use that information to find our x-intercepts and our axis of symmetry. So first thing I want to do here is take a look at what I've got going on. I've got a couple of 6s. So I know that I can factor out the 6. And basically I'm not really going to use that much at this point. But I got 6x plus 1, x minus 1. Remember, this is the difference of squares. So if I'm looking for the zeros on this, now that I have this factored out, I can say that x equals 1, x equals negative 1. I should have switched those, but that's okay. And because this one goes with this one and this one goes with that one, but that's all right. So then you get 1, 0, and negative 1, 0. Those are your x-intercepts. If you want to find your axis of symmetry, you take 1 plus negative 1 divided by 2, and you get 0. Okie doke. Let's try another one. So I want to actually solve this and put it in that format. So this is where you factor. So if you recall, we factor. We do 20 and 9. So two numbers that multiply to equal 20 add to equal 9, or 4 and 5. So you get x plus 4, x plus 5. And once you get it into this format, you can see that your zeros are when x equals -4 or x equals -5. Sorry, that's a negative. So my points here are going to be -4, 0, and -5, 0. And my axis of symmetry is when x is -4 plus -5 divided by 2, or -9/2, which equals -4.5. Okay, so we're just taking the factored form, finding our zeros, and we're going to use those now to actually graph. So I pre-did my graphs on here so that I could actually not make this video 100 minutes long. However, I would take a minute to actually use the graphs that I have, or write them down before you go through each example. Maybe pause for a second to do that. And then all you got to do is look for your zeros here. So x equals -5 or -1. So at -5 and -1, these are my zeros. And my vertex is going to be all the way down here. So my vertex is where my axis of symmetry is. So if you want to figure that out, it's really fun to do, because you can just do -5 plus -1 divided by 2, and you get -6 divided by 2, which is -3. So at -3, I know this is my axis of symmetry. Let me use a different color here. So what is the value of this at -3? Well, -3 plus 5 times -3 plus 1 is 2 times -2, or -4. So my vertex, vertex, I'm just going to put a V there, is -3, -4. Should have put a negative there. So -3, -4 is right here. And then you can see your graph. It actually is going to go through the axis at about 1, 2, 3, 4, 5, right about up here. And whoop, and then you get your graph. So actually this should be slightly higher, but it's all right. Your domain is going to be all real numbers, and your range is going to be the y value of the vertex. So y greater than equal to -4. All right, let's try that again. Sorry, I'm sniffing a lot. No particular reason. Thinking it's allergies. Okay, so let's try it again. You get x is equal to 3, or x is equal to 1. That's your zeros. If I plug a 3 in here, makes this 0. If I plug a 1 in here, makes this 0. So if I want to find my axis of symmetry, I'm going to do 3 plus 1 divided by 2, which is 2. It means my axis of symmetry is right here. That means my graph is going to be symmetrical on both sides. So looking for -4 times 2 minus 3 and 2 minus 1. So -1 times -4 times 1. So that is 4. Sorry, no, you couldn't see that. So that means my vertex is at 2, 4. So 2, 4. I know my graph is going down because of this negative right here. And I know that it's going to intersect at 1 and 3. So it's going down fairly quickly. My domain is all real numbers, and my range is that y value right there. So all values less than or equal to 4, because it's going down. So it's less than versus this one, which was greater than. Okay. I'm going to quickly do these other ones because I don't want to keep you on here for the rest of the day. But x plus 2, x minus 2, difference of squares. That means I'm going to be at a plus and a minus 2. So that means that and that here. It's going to be positive, and this is going to tell me that it's going to be at -4. So it's actually down here. So that right there tells me it's at -4, the y-intercept. And there's your graph. Not super pretty, but you get the idea. Try to make those more you like. All right, last one of these. Oh, sorry. The domain on this and the range. Okay, last one of these. And then we'll try a couple others below that. So if you factor this, you get x plus 5, x minus 3. So that means my zeros are at -5 and +3. And -5 plus 3 divided by 2 is going to be -1. Sorry, brain fart. I was like, what? And notice I did this graph by threes. So this is 3, 6, 9, 12, 15. It was because of that right there. I know that I'm going to be at -15 to start with. And, excuse me, and I know that it's going to be at 3 and -5. So you can see this graph is really thin. Very thin graph. Okay, so your domain, all real numbers, and y is greater than or equal to -15. All right, 2 more. They'll be quick. So this is x plus 2, x minus 5. So x equals -2 or +5. These are my, notice I did this by twos, 2, 4, 6, 8. So these are going to be my intercepts, -2 and 5. And I'm going to go all the way down here for my vertex. Or sorry, well, actually, it's not vertex, it's my y-intercept. So all the way down here. Whee. Okay, so this right here, if you have your axis of symmetry, -2 and +5 divided by 2, your axis of symmetry, you will end up with 3/2. So that's why this is going to be more like over here at 1.5. And that's why I knew it wasn't exactly on the 10. It was going further than that. And last one. By the way, I'm going kind of fast on this one, but we've done a lot of graphing already, so I know you guys get how to graph. It's just taking one extra little thing here and making this your zeros. So if you're wondering what I'm doing, I'm just using the zeros in the graph itself, and then working from the axis of symmetry to find the vertex. And the axis is always going to be from these numbers, the average of those. So you got 3. So x equals -3 or x equals 1. So x equals -3. This is my axis of symmetry, plus 1 divided by 2. So -2 divided by 2 is -1. And that's my axis of symmetry. So it's going to be right here, axis of symmetry. I didn't draw it out on all of them, just a couple. But this is actually -3. 1, 2, 3, and 1. And you can see the distance from here to here is 2. The distance from here to here is 2. And I know that my vertex is going to be at -1. So if I plug -1 in here, I get -1 plus 3 negative 1, minus 1, so negative 2, 2, and negative 2, which is 8. So it's way up here. 1, 2, 3, 4, 5, 6, 7, 8, right up here. Oh, I actually did it earlier. So, big old graph. Whee. You guys can make it prettier, I'm sure. Okay, that is this lesson. See, I kept it to 15 minutes instead of going to 20, and that was rushing. But hopefully you got the idea of how to use the zeros to help you with your graphing, and also find your intercept and use that to actually find your vertex. Let me know if you have any questions.